Welcome to this presentation on my work on automated generative conversion of the XML templates, otherwise known as meta-DTDs, of the NeXus format into XML schema. I call this the NeXML sub-project, a child project to the parent project NeXus. The idea being that it is supposed to be consuming independently artifacts, the XML templates from the NeXus project. Now I have those here on file. You'll see here in my NetBeans project that I have locally stored the latest versions of the XML templates from SVN. Just open one up, see the familiar templates. These will be mapped to complex types in the schema. These will also be mapped to complex types in the schema. And one of the big topics for discussion is how to achieve these constraints and also dimensionality. We'll look at that in detail later. Okay, so in my NetBeans project here, you'll see that I also have latest versions of the schema files. This one here is imported by my system. It optionally leverages some of the definitions in the base schema. See here I have a UML project to go with it. Being a UML fan, we'll be looking at some UML diagrams of the system later. So I should say before proceeding, these classes can be consumed, digested directly from SVN, but I have a number of operation modes for testing. It's obviously easier to do it locally. Okay, so here's the Java code that performs the conversion. There's a reusable base of definitions of concepts that appear in the NeXus templates. In particular, the NeXus types. You'll see that I've encapsulated there a lot of the reusable ideas, and also I have a way of interpreting the multiplicity kinds actively. In Java you can actually have operations in an enum, very useful indeed. The main work is done here in a tool package. You'll see I have a NeXus factory for spitting out XSD or XML schema encapsulations of concepts in the NeXus templates. And the NeXus templates and the child elements of those templates are encapsulated by these interfaces and classes. So for each template, you see it corresponds to a DOM4J document. We'll see this soon in UML. And for each element, there's a child, and at the moment it's a kind of catch-all class which is able to distinguish between a group, scalar data items, and vector data item children, and it's also able to extract the comment, dimensionality indicator, and documentation and so on from units attribute from the element, the NeXus template and child element. Now the entire system has a concept of a project, and you'll see that I've got SVN project as a specific implementation of the project interface. This enables you to choose between streaming from the SVN directly or from file. As I've shown, I have the XML files locally. This system builds on the old NeXus beans, prototype NeXus beans. You'll see a little red indicator here This is no longer maintained. The big shift is that this system, which uses the XSD library from EMF and the Eclipse Foundation, generates the NeXML schema. We'll be looking at the schema in detail shortly. And there, a brief view there of the complex types corresponding to the classes automatically generated. It does also, you'll notice here in the source, import the NeXus.xsd base so that it can optionally use some of the IDs. Now, you'll notice I'm working in NetBeans. This is because I like certain aspects of NetBeans, especially for XML editing. However, the basic EMF system runs in Eclipse. So later we'll be looking at the XML schema also in Eclipse, and we'll be looking at the EMF instance model editor, which validates against the schema. Okay, so let's give it a fly. From anywhere here I can, I think this should work. Running. Okay, so you'll see here, very quickly running past, lots of debugging information about the templates, and there is the generation of the schema. There we go. You see it takes 14 seconds. In fact, it only takes a couple of seconds if you don't generate all the debugging information. Now, if I go to the top of this output, you'll see, just bear with me, you'll see I give quite a lot of information as I go. I say which files have been processed, and for each file I say which one I'm converting. In this case it's NX Aperture, and it's giving information on the group, the data item. Some of the data item names need to be remapped. That's also indicated. I spit out the documentation and so forth. Now occasionally you get warnings. For example, no known Nexus multiplicity indicator found in Nexus documentation, distance from sample. So the system provides, just as a side effect, a huge amount of extremely useful diagnosis of the templates. The basic aim is to see whether or not we can keep using the Nexus templates. However, it will necessarily, it needs to be redesigned, there's no doubt. Okay, so let's now move to look at the schema. For this presentation, I'll be using the NetBeans Schema Editor. It has a useful cascading schema view, and we see here the NeXML generated schema, a single name attribute. I'm not handling the global attributes so far, I consider it trivial. Here are the generated complex types. There are also some base types such as NX Geometrical and NX Object, which are generated specifically. And there are some extra data item types. I'm trying to reuse data items as I did already in NexusBeans. However, it turns out that, for example, distance is used in many different forms, even with different units. Okay, I'd like to look at NX Aperture and NX Attenuator. In the cascading view, we see that I'm using a sequence. All, unfortunately, doesn't work for it. The all grouping has a few restrictions that won't generalize. And we see I have description and material generated as complex types, and so on. You can then work your way into the type. Now, for each data item, like material and description, you'll see that I have here a specific type and units attribute which has been generated on a per data item basis to afford later restriction. In other examples we'll see that the units can be restricted, as can the type. Okay, so as well as the generated complex types for the NeXus classes, there are a number of fine-grained data items which are there in order to encapsulate list, or in some cases lists of restricted size, as we'll see. The NetBeans view also gives a simple tree, so if we go to NX Aperture, you'll see you can likewise navigate the schema. Here's NX Attenuator with its data items. You can of course also go to the source. If I select a particular item here, I can go to the source, and there's a so-called design view, which is more like some of the commercial schema tools. I'd like to briefly summarize in UML some of the aspects of the transformation mechanism in Java. There's a base of reusable concepts from NeXus and NeXus Design. The actual conversion takes place via a simple service, convert, which has a project. A project is a collection of XML templates. The project can be from file system, or it can be streamed from SVN. Each XML template is encapsulated as a DOM4J document, and the child elements are encapsulated through a DOM4J element. These then are mapped by extraction of strings from the templates and the elements of the templates, the child elements, to strings which can then be mapped through a factory to XSD elements such as XSD complex, XSD attribute, element, import of an external schema such as nexus.xsd, and so on. So this is the Eclipse XSD system. Once the NeXML XSD schema has been generated, it can be reverse engineered into graphical UML representations. Here we see the NX object type, which is the base of my system. It's an XSD complex type, as indicated here by the stereotype. Attributes are also indicated by stereotypes. This is otherwise known in UML as the attributes compartment, so one has to be careful. This is a property of a class. Such property, for example, here is a property, can be represented as the end of an association. This is the type of the property, and extra name is the association. There is the multiplicity. And by the way, this extra name you've seen there is to prevent a clash with the name attribute of objects. So here we see NX instrument type. Here are the properties in the UML attributes compartment, but these are in the schema elements of the instrument type. Now one can optionally drag these out. For example, NX source here is a property, and I've chosen to also still display it in the attributes compartment. So here is the property NX source of type NX source type, multiplicity 0 to unbounded. Here is the same property at the end of an association. This is the association relationship. And we can also show the same property in the structure compartment of a class. You'll see that it's an NX group. This is an abstract type I've included to improve organization of the hierarchy, and groups are of course also objects. Okay, here I'm showing the geometrical classes. This is legacy from NeXus Beans, where I already had a geometrical type, similar to the component in the NeXus.XSD, except it doesn't yet have a location. And the reason I've kept it is to experiment with automatic translation of the NX geometry rather than doing it manually, just as a matter of principle. And here we see the hierarchy of geometrical classes. Okay, I have here an overview of the NeXML base types as seen in XSD. Now, the hierarchy is based on the NeXus Beans hierarchy with an NX object that has a name. And like NeXus Beans, the prototype NeXus Beans, it has an abstract Nexus group. Geometrical type we've seen with geometry, and there's aperture would be an example of a geometrical type. But notable is that I'm not using the data item hierarchy. You'll see there I had a scalar, vector, and multi-data item, abstract types extending a generic NX data item type, which used to have units, for example. Now, this is not working in XML schema, at least not that I can discover. It seems to block the ability to generate unit and type dimension per data item, or to restrict a general data item type data item attribute like unit. I'd like to ask you to bear with me as we look in detail in UML at what I consider to be the big issue at the moment, both with the manually designed NeXus.XSD strategy and with my conversion system. The question arises how one can restrict data items to take a specific type as indicated by the NAPI type type attribute, specific units and specific values. And I'd like to present one strategy for it here. It's a little bit bloaty, but does seem to work. Okay, so first, for orientation, I have here the NX sample type, which is a complex type corresponding, of course, to the NX sample template. Now, what I've done here is I've created associations to a number of types for properties. I'll just review these again carefully. We have type is the name of an element, and I've deliberately chosen it because it happens to also be the same name as used for the attribute type, and we see that my system is able to handle such cases. It's clearly marked here as an element. Orientation matrix is another data item element. There's its type. You'll notice that it's quite verbosely marked as anonymous type here. That's just part of the UML import mechanism. I have here concentration. It has a concentration anonymous type. It happens to be a list, and we have down here sample orientation, and in this case it has length. It extends a finite data type, especially on the fly created class. Okay, so let's look from the top at this in more detail. These are the types of samples, is the way it's to be understood, and the system has created here enumeration literals corresponding to the different types of samples. We have sample environment, none, simulated data, normalization sample, calibration sample, and so on. Now, independent of this enumeration restriction, it has, as every data item in my system has, its own type and units. In this case, they are able to be created inline as anonymous types, and we have no further information about what the type of the type data item should be, nor about units. However, in this case, we do have some information. The orientation matrix, it turns out, we know is restricted to be at least a float. However, more than that, we know that it has a particular dimensionality. Now, I've not yet figured out how to handle parameters like this in the system. It may be possible, but they're not formally defined in the templates. There's another case down here, ncomp. Even if it appears in documentation elsewhere in the templates, there is a need for formal declaration of it, and then perhaps using key refs or some strategy like that in the XML schema, it's possible to create an appropriate constraint. We see in this case that we also have an enumeration for the units. The units were given, they're not available in all data item elements in the templates. They're available, of course, just as a string at the moment, but to the extent that they are known, the string can be enforced. It's saying that an XML instance file must give exactly this string to declare units. I just forgot to mention the dimension indicator here. At the moment, I just propagate through and enforce, so in cases like this it doesn't work. Now let's look at, finally, a case where the dimension is known and finite. The data item type and units are given here as just attributes, as in UML attributes, properties. I've chosen to show a dimension. You'll notice I'm separating the type from the dimension. There's the dimension that's been extracted. It will be enforced in the XML schema. And also we see, and here's the big trick, that the length facet has been used, or we can see that the UML extracts that correctly. We have here a value of 3 for the length facet relative to this sample concentration data item. To achieve that, it uses a finite data type base anonymous type, which is bound eventually to float32. In fact, this happens through the nexus.xsd NX float32 type, but it's just resolved it already to the XSD float32. Okay, let's see quickly what happens if you then load the NeXML XSD schema into Eclipse. You'll see here that it's loaded the schema as a gen model, which is a translation from XML schema space to a canonical space that EMF uses. I've got here the two schemas. The _3 is just from the namespace indicator for nexus.xsd. This is the familiar nexus.xsd base. And there's the generated NeXML schema with lots and lots of data types. I'll just scroll quickly here. You'll see, for example, description here is repeated many times, but they're not all identical. Same with distance. On closer inspection, you see that they are slightly different from each other. So there's definitely a need here for reuse. Here's the generated base class types, and just scroll down here, you'll see these types. Lots and lots and lots of, try that again. There you go, units. So I'll try again. Units types, 300 or so. There's more units types. Types, which are subtypes of types needed for the restriction of the NAPI types. And here we have lots of list types for the different data types. per data item, of course, and some of them will be enum data types. Now, once you've got your basic EMF project, you can then generate an editor and edit system automatically in EMF. Let's now see how that works. Okay, once your schema, in this case NeXML, is loaded into the EMF system, you can run a specific editor for it. Here I have a document root and an NX root. Here's an NX entry. I'll just show that you can make a new NX entry. You'll notice that the children are validated. For example, new sibling, you can only have an NX entry type. Inside an NX entry type, I could have a new instrument, a new user, a new monitor, and so forth. New sample. Now, I've actually already set a couple up here. Just for demonstration, show that we can add more than one chopper. There we go, different types of choppers, and so on. Now, to investigate the data items, I've already set up here the NX sample that we investigated before for the types, restrictions, units, and dimensions. Okay, so let's start firstly with the simple concentration. You'll recall that the units were available for it, and there they are. There's no possibility to do anything with those. It's a simple enumeration literal, but there's only one of them. The type, NAPI type, is indicated here as NX float. The dimension has propagated here as a string. There's no way of overriding that either, because it's simply an enumeration literal. It's essentially metadata. Now if I try to put a value in, that's nonsense. You'll see down here that the EMF system is complaining about the type. So there's not a bad degree of validation there. So we already have units and a value. That's better than nothing. So let's look at the type. Remember, it's the type of sample, and it itself has a type. It's NX char, but again, this is just considered metadata. The actual validation comes through the value. Now, you see how it's provided from the enumerations, the possible values. I'll just change it to show that we can do it. Let's look now at cases with dimensions. Now, you might recall that I think it's the sample orientation, there it is. NAPI type is NX float. The dimension here is forced. Again, it's a string that just acts as metadata. Units propagated, and if I now try to enter a value, you'll see already it says the value must have length 3. Now I'll try to put in 2 values, and it complains. We must have 3. If I try to put in more, it complains. I have to have exactly 3. Alright, so that's a valid vector for that. And for this one, where we had ncomp, a parameter, there's no way of knowing what the number of total list size is, so I think we can put in here anything like. And that will accept it, it's just left open. Now if I save that, we can also look at it in XML, and you'll see seems to have some minor errors, but we have an XML file. I'm not sure in this case what the errors are. You'll see that the schema has been imported, and actually we'll have a quick look and see if we can find out what the problems are. I'm not sure at all why it's not validating. Validate. No errors or warnings. So I'm not sure what the underline's for. There are no errors or warnings in the files. There you go. a NeXML file with data and validation against a schema. Not complete, but well on the way.